So in this video, I'm going to discuss the equalize by divide problem which occurred in today's CODEFORCES challenge. So if you have any doubt regarding this, you can ping me up on Instagram. Even you can join my Discord server. I provide both the links in the comment section. I will pin them. So this question is very simple. It states this is the number of test cases. This is the value of n. That is the number of elements in the array, and this is the array. So you have to like choose any two indexes I and j, and replace ARR of I with x, that is an integer, which is the minimum integer which is greater than equal to ARR of I by ARR of j. Okay, very simple thing. So and we have to check that if it is possible to make all the elements of ARR equal or not by operating the operations a specific number of times. If it is possible, we have to print the number of operations that we need, and then the operations, that is I and j respectively. And if it is already equal, we can directly print 0, because see, for this 100 only one element, for this 111 it is all are equal, and over here 5 and 5 equal, so 0 0 0, and 2 and 1 it is never possible, okay, to make them equal, so it becomes -1. Okay, so this is a very simple thing. So let's move on to the code. So let's say we are going to use the stack concept. Now remember one thing, how we are going to implement it. Since if you watch the whole question very minutely, so it is stated that there is at most 30 into n steps. Okay, it can be made equal into 30 into n steps, and if it can't be made, then even in 30 into n steps, even after 30 into n steps, it won't be equal. Okay, so this is a very easy thing to notice, and if you notice this thing, then you can come out with the approach that this is a greedy approach. Okay, and so this is a greedy approach. Let's say we have a stack of size 30 into n, okay, and 2, because this thing we are going to store in this stack. Okay, and let's say for stack, the thing is top, so top is initially 0, like it should be equal to -1, but we are just considering that top is equal to 0, that is just 1 ahead of that. Okay, that is top plus 1 basically. So for this, we have to run a while loop while all elements of array are not equal. Okay, all elements of the array are not equal. So what you have to do is, let's say, okay, we can do one thing. For I is equal to 0, I less than n, I plus plus, that is traversing throughout the whole array. Okay, first of all we have to find the minimum, right? So minimum is equals to 10 to the power 9 plus 1, and the position of the minimum is equal to -1, just considering the initial case, and then run this loop. And if ARR of I is lesser than minimum, so we can replace minimum with ARR of I, a very simple thing, that is finding the minimum, and position of the minimum will be I, right? So once we are done with this, now we go to the next part. Okay, what is the next part? All the elements which are not minimum, we have to convert it to this thing x. Okay, convert it to this thing, that is ARR of I by ARR of j. So that is for I is equal to 0, I less than n, I plus plus. Now int previous is equal to ARR of I, actually not over here. So if ARR of I is equal to minimum, so dividing it would make it 1. We are not going to consider it. Okay, we are not going to, it is the last possible approach that we have to consider. We have to make all the elements 1. Okay, so if it is not equal to minimum, then we can do one thing. We can okay, let's say previous, the actual value of ARR of I is ARR of I, and then we have to perform the operation on ARR of I. Okay, ARR of I is equal to ARR of I by minimum plus, if you know the ternary operations, so you will get this. So if AR of I mod m is greater than 0, then add 1 to it, else add 0 to it, that is keep it the same thing. And if previous not equal to AR of I, flag is equal to 1. Okay, flag you have to initialize as 0 initially. So flag is equal to 1, and this is just a thing. Okay, if previous is not equal to AR, that means after performing the operation on AR of I, the value of AR of I has changed. So if it has changed, we can write that flag is equals to 1. So why is this necessary? Because if in case if after doing this, if flag is equal to 0, that is even after performing the operations throughout the whole array, no element has changed. So we can guarantee one thing, that if we perform the operation again, no element will change. Again, no element will change, right? No matter how many times you perform, the elements won't change. So if flag is equal to 0, we can like print -1, okay? And then like the continue thing or the break thing, whatever, okay? Continue or break, okay? So this -1 condition we have got, 0 condition we have also got. How? I'll let you know. So once we are done with this, at this position, when we are going to make this, so we are going to add, like remember I told you about the stack thing, top and this two things. So we are going to make stack of top of 0 as what? The position that I am presently in, and what I am dividing it with? The minimum element, right? So what is the position of the minimum element? That is pause, right? Remember, pause is the position of the minimum element. So this is the position I am presently in, and pause is the position of the minimum element. So once we are done with this, now top plus plus, the implementation of stack, you implement top plus plus. Now see, if all are equal, right? If all are equal, that is all elements of array are not equal, then only it will go into this loop. If all are equal, it will never go into the while loop. So what will be the value of top? It will be 0, right? So top is the number of operations that we have to perform. So if all are equal, then it is 0, right? So we get it, right? Now you know that how can we get the 0 thing? So the while, this is the end of the while loop, okay? End of while loop. I think it's like too clustered my writing, so for better understand, I'm writing this at end of while loop. So then you have to print what? You have to print top, right? The number of elements. And once you have printed the top, so run a loop from I is equal to 0 to I less than top, I plus plus, and what you have to print? You have to print this, okay, I plus 1. Remember one thing, I plus 1 and position plus 1. This is because in the question it has been given that you are going to use 1 based indexing, not 0 based indexing, okay? So you have to print stack of I of 0 and space stack of I of 1, okay? I think this whole thing is very clustered, so it's really difficult for you to understand. So let's do it with some example. Let's take this one, okay? 3 4 3 2, okay? 3 4 3 2, 3 4 3 2. Now check, what is the minimum element? 2, right? So we have to divide all the remaining elements which are not equal to minimum, that is 4 and 3, by 2. So 4 by 2 is 2, 3 by 2 is 1.5, and for x the integer which is greater, the minimum integer which is greater than equal to 1.5, that is 2. So 3 also becomes 2, and this is what? 2. So how many operations we performed? We performed 4 and 2, and then 3 and 2, and all elements are equal now, okay? So check this, we've performed 1 and 3, that is 1 and 3, right? And then we perform 2 and 1. See, it over here it is written that we have to perform 2 and 1, but what we did, we performed 2 and 3 instead. That is what I basically told. But once you have performed 1 and 3, so 4 becomes 4 by 2, that is 2. So basically this is also, no matter if I divide 3 with this 2 or 3 with this 2, doesn't matter, the answer remains same. So this is how the maker of the question confuses you. Okay, so let's take one more example, this 4 3 3 4 4, so that the whole concept will be clear to you. 4 3 3 4 4. What is the minimum element? 3. What are the elements which are greater than minimum, that is which is not equal to minimum? This 4 and 4. So we have to divide 4 with 3. So what it becomes when we divide 4 with 3, it becomes 1 point something. So to round it off, like to this x thing, this becomes 2 and 4 becomes 2, right? So what is the new thing? New array 3 3 2 2. Now what is the minimum? New minimum 2. So 3 by 2, 1 point something. So 3 becomes 2 and this 3 becomes 2. So what are the elements? 2 2 2 2, right? All are equal, right? All are equal. Very simple. Now see how we came to this. 3. What was the minimum element? 3, right? That which was at the position 1. So what we have to do? We have to make, so this is 1, this is 2, this is 3. This is 3 and this is 4th position. So we divided 3rd position with 1st position first, then 4th position with 1st position second. Okay, check this. We divided 3rd position with 1st position first, then 4th position with 1st position second. Then what we did, this was 3 3 2 2. So this was 1st position, this was 2nd position, this was 3rd position, this was 4th position. So we divided 1st position with 3rd position then, and then 2nd position with 3rd position, right? See, 1st position with 3rd position, 2nd position with 3rd position. So what we get finally? 2 2 2 2. Sorry, this is okay, 2 2 2 2. Yeah, this 2 is. So this is the basic thing. So what is the basic approach? Find out the minimum, divide all the elements other than the minimum, which are not equal to minimum, with minimum, and continue doing it until the array becomes, all the elements of the array becomes equal. And if at any position you find that even after performing the operation throughout the whole array, the same thing is repeated, that is there is no change, that even after performing the operation there is no change, so we can simply say that this thing is not going to work, so we can print -1. Okay, this is a little complex but a nice question. That's it. Thank you.